So we are working on the properties of logarithms, and we have one left to learn. And that is property 3, which is the power rule. It says log base b of x to the power is equal to the power times log base b of x. So basically it's saying if we have an exponent in our log function, that exponent can be written as itself times the log function. So we can take it from the exponent and pull it down in front. Okay, so let us prove this. So my first step is I'm going to make a substitution. I'm going to let m be log base b of x. So we can actually see that two different places here in my power rule. So I'm taking this, and then we're going to show how I can move about that power. Okay, the very first thing that I want to do with this is I want to put this in exponential form. So if I put it in exponential form, that gives me b to the m power is equal to x. And then I want to take this equation and I want to raise it to a power. And I know that if I take both sides of an equation and I raise it to a power, that's okay because I'm raising it to this exact same power. Now, if I look at my exponential rules, I know if I have a power to a power, I can rewrite that as multiplication. So b to the mp is equivalent to x to the p. Now I want to change it back into logarithmic form. Okay, so we know that if we have a base to some power is equal to x, that's the same thing as log base b of x is equivalent to y. So whatever my base is, that goes to the base of my log. Whatever my exponent is, it goes to the opposite side of my equation. And whatever x is, that's my argument inside my log function. So changing this back into log form, I have log base b of x to the power is equal to my exponential power, mp. Okay, well, I'm going to make another substitution back in then. In my original problem, I said that m was equal to log base b of x, so I'm going to substitute that back in for this m right here. So that is equal to log base b of x, and this is multiplication, so this is times p. Well, I have what I need. All I need to do is rewrite this. So I have log base b of x to some power is equivalent to the power times log base b of x. And now I have just proven my power rule. Okay, so what I need to do now then is I just need to start applying this property in specific examples. So let's jump right to it. Okay, so we have 3 examples here. I have highlighted the power property up top. And so I suggest that you pause the video to simplify these and to basically rewrite these where my power becomes the multiplication factor in the front of your logarithm. Okay, so it's as easy as it looks. In example 1, all I need to do is take my power of -3 and I need to move it out in front. And so that is equivalent to -3 times log base a of 11. And that's all I need to do. If I could simplify anything, I could, but I cannot, so that is what it is. In example number 2, natural log of x to the 6th. Again, all I do is I take that power and I move it out in front. And so that gives me 6 times the natural log of x. I cannot simplify anything farther, and so this is my final answer. Number 3 is definitely the most difficult because it does not look like it resembles that it has a power. Well, we need to get used to rewriting things. We had a property back in the exponent section that says any root can be rewritten as an exponent. So if I have the nth root of x to the nth power, I can rewrite that as x to the n over m. So in this case, I have the 4th root of 7 to the 1st power, so I can rewrite that as 7 to the 1/4 power. So this is equivalent to log base c of 7 to the 1/4, and now I can apply my power rule. So even though it didn't look like I had a power to begin with, there's always a chance that you can manipulate it so you in fact do have a power. Applying my power rule is easy. Just bring my 1/4 down, and that gives me log base c of 7. I cannot simplify anything farther here, so this is my final answer of applying my power property. Okay, so we have learned every single property, and so let me just show you all of the properties at once that we know for our logarithmic function. We have the 4 properties on the left that we learned in the last section that shows us when certain things of logs cancel out. We have properties 5, 6, and 7, which we've just learned in this set of videos. And then, of course, we have the change of base formula. And that is useful for when we actually want to figure out the approximate values, and it is not for a common log or a natural log, so we cannot just type it in our calculator. What we're going to do in the next video is we are going to work at examples that applies all of these. So you need to be able to figure out how to combine all of these at once to simplify all different variations of logarithmic